Hello students, welcome to all of you in my YouTube channel. I am Dr. Himanshu Sarkar. Already I have discussed the electric field intensity, potential, dipole, end-on position, electric field intensity, broadside position due to dipole oscillation. Lots of things I have discussed in my last few lectures. Now I will discuss how to calculate electric potential due to a charge q at distance r. Before that, I request to all of you to subscribe my channel so that all of you can view my channel contents. You know, my aim is that to find out electric potential V due to a charge q at distance r. My target to find out electric potential V due to charge q at distance r. How to do it? This is a charge at distance r. You have to find out potential at point P. P is what? At distance r from the charge q. My target to find potential at P due to charge q at distance r. How to do it? That is, all you know, what is the relationship? Already I have discussed in my last lecture. I have discussed how to find out electric field intensity and what is the relationship between electric field intensity and the potential relationship. I have already discussed. What I discussed? E is equal to minus dV dr. So you know what is the electric intensity at point P? You know E is equal to, already I have discussed, 1 by 4 pi epsilon naught into Q by R square. You know it. So from this equation, two equations, equation number 1 and equation number 2, we can write down. So from 1 and 2, I can write down minus dV dr, that is equal to what? 1 by 4 pi epsilon naught into Q by R square. So from these two equations, I can find out dV is equal to what? dV is equal to what? Minus 1 by 4 pi epsilon naught into Q by R square dr. Okay. So if we integrate this dV is equal to what? Minus 1 by 4 pi epsilon 0 into Q by R square dr integration. dV integration you know V. This integration you know minus 1 by 4 pi epsilon 0 into Q into minus sign of Q by R plus some constant that will come. She is called integration constant. Why minus Q by R? Because we know integration of dr by R square is equal to what? Minus 1 by R plus some constant called integration constant. Okay. So ultimately we can find out V is equal to 1 by 4 pi epsilon naught into Q by R plus C. Now to find out the value of C, we will consider some boundary condition. What boundary condition? All you know that infinity, when R is infinity, potential becomes what? 0. All you know. So when R tends to infinity, potential tends to 0. So 0 is equal to 1 by 4 pi epsilon 0 into Q by infinity plus C. All you know, something by infinity is what? 0. So ultimately you can write down, that is 0 is equal to this part 0 plus C, that means C is equal to 0. So potential is 1 by 4 pi epsilon 0 into Q by R. I think students understand this, no problem. So what we have learned? We have learned due to a charge Q at distance R, at this point P, what is the potential? 1 by 4 pi epsilon 0 into Q by R. I think clear to all of you? This formula is very important, and note one thing, intensity is a vector quantity and potential is a scalar quantity. This formula is very much important. So I am stopping my class here. Thanking you.